Hello everyone, my name is Rishabh Pandey and I am a physics faculty at askIITians. Welcome to the second lecture of electric current and its effect. In the first lecture, we discussed all the basic concepts of the current. We just did talk about the electric circuit, the electric diagram, and what's the functioning of the potential difference, how does it control the current, right? And in the second lecture, we'll be talking about the Ohm's law. The Ohm's law. See, as I told earlier in the previous lecture, that for drawing the current, it needs energy, and that energy is provided by the potential difference. But in between that, when it is consuming potential difference, it is having some resistance. Like, for example, if you try to understand this in a way that we have a circuit like this with a bulb connected over here, and this as the connected by a battery with this as a filament. The filament is made up of, do write that, the filament is made up of. See, point is that when the current flows from here, let's say here it has a potential difference of V, here it has a potential difference of 0. Here the potential difference will be V because it will not be consumed by the wire. In the ideal situation, we accept that. Then here the potential difference will be V, followed by here, and here we have the potential difference 0. That means from this corner to this corner, the potential difference is decreasing. There is a potential drop. Potential, it is facing a situation of potential drop, and by the term potential drop, I mean that the potential is decreasing from V to 0. That means someone is consuming it. That consumption is basically due to the concept of resistance. In the ideal situation, we do accept that wire has no resistance. Wire has no resistance in the ideal case. So since wire is not having any resistance, that means it will not consume any kind of potential. That means, as you can see, from here to here, no potential consumed V. Here to here, here the potential difference will be 0, and so the potential consumption is 0. Point is, why is it 0? Because of 0 resistance. Are you getting this? So point is that the resistance is responsible for consumption of the potential difference. Is this thing clear? Now, what does Ohm's law says? Ohm's law tries to give a relation between the current and the potential and the resistance. It says that V is directly proportional to I. We did talk about this in the previous session, that if V increases, the current also increases, the rate of flow of current increases. So if I increase the V, current will increase. Are you getting this? As you can see in this graph, it's V versus I, and this line is like this, it's slant height completely. This shows that V is directly proportional to I, and we get a graph like this. And here, since V is directly proportional to I, so the proportionality constant is R. So as we have V is equal to IR. There's a formula, as you can see over here. V is equal to IR. That means it gives you a relation between potential, current, and resistance. That means it is a kind of important thing, right? Now, few more things regarding resistance. If I talk about here, resistance, responsible for consumption of potential, responsible for the consumption of potential, and the unit of resistance. Unit is ohms with a symbol this as a symbol of resistance. And this is the formula, obviously, that V is equal to IR, right? As you can see over here, the symbol is given ohms, right? Now, the resistance basically, as I said, that V is equal to IR, V is equal to IR. But there are various factors on which this resistance depends. For a particular situation, resistance depend upon various factors. Depend on factors. Factors such as area, length, and nature of material. Nature of material. What does this mean? Say, I have in this room, I have a capacity of making 20 people sit comfortably. Right? In this room in which I am sitting right now, I have the capacity of making 20 people sit comfortably. Suppose in the same room, if I'll make 100 people sit, will they be comfortable enough? No, obviously not, right? In that situation, what I should do is, what I can do is, first thing, I can increase the length of the room or increase the area of the room, or let's say if I try to keep the room temperature down, and if I switch on the air conditioners and so that everyone should be calm and could be adjusted somehow. So these are the three factors on some that which decide that if the people in this room will be comfortable enough or not. Similarly, if I talk about the wire, there are various electrons and charges, and if I need to increase the resistance between them, or if I need to decrease the resistance, because it has already a large number of electron, right? Large number of electron, large number. So here I can increase the length or the area. This is the cross-sectional area, and this is the area, right? And this wire has a kind of resistivity. Right? This is area, and this is a nature. Our rho is like the nature of the material. So the nature of the material has been symbolized as rho. Length has been symbolized as L, and the area has been symbolized as A. And from all of these factors, I can say that R is equal to rho L upon A. Resistivity into length upon area. Nature of the material is resistivity. This is called as resistivity. L is called as length and A is called as area. Are you getting this? Right? So these are the factors on which the resistance of this particular wire depends. Right? Now, these resistances could be in various combinations. And this is one of the most common questions which we generally get. That combination of resistances. Combination of resistors. There could be various combination of resistors. The first type of combination is called a series combination. The one which you are seeing over here. This is the series combination. And the second type is called as parallel combination. Parallel combination. For series combination, the formula is R is equal to R1 plus R2 plus R3 plus dot 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 up to Rn. Rn is like infinite number. And say there are infinite situations. And for R parallel combination, we have the formula as 1 upon R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot 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 up to 1 by Rn. This is the case of parallel combination. So it depends upon the case to case basis. Like if you see over here, all these three are the example of series combination. Series combination. And since it is a case of series combination, the equivalent resistance will be R equivalent R1 plus R2 plus R3, right? And in this case, this is an example of parallel combination of resistors, right? This is the case of parallel combination. And since it is a case of parallel combination, you can see that here the current which is flowing, say I current is flowing over here. This I is getting divided into I1 plus I2 plus I3, as you can see. say one current charge and then splits into 3. As it comes over here, splits into 3. And so in this situation, we have the R equivalent as 1 by R1 plus 1 by R2 plus 1 by R3 plus up to where 1 by Rn. This for this, if I want to find R equivalent, then it will be 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Right? Say in this situation, I need to find the equivalent resistance in this circuit. Here I need to find the equivalent resistance in this circuit. If you see, if you look closely, you will find that this and this is in series combination. This and this is in series combination. Suddenly you cannot do that exactly. You cannot say that these three are in parallel combination. No, you cannot. You have to simplify it step by step, step by step. Say when I'll solve these two, it will become R1 plus R2. R1 plus R2 is like 10 plus 2, that is 12 ohms. So instead of this, I will have one resistance like this, combining these two. These two will cancel out and this will be like 12 ohms. Then these two will be parallel combination. 6 ohms and 12 ohms. 6 and ohms and 12 ohms in parallel combination will be 1 by R is equal to 1 by 6 plus 1 by 12. Will give me 1 upon it will be total by 12, and this will be 2 plus 1, that is 3 by 12, and so the R equivalent will be 3 by 12, that is 4 ohms. So combining these two, I'll get one resistor over here which will be like 4 ohms. These two will combine and this will give me 4 ohms. Now this 4 ohms will with this now behaves like a series combination. This 4 8 behaves like 12. As soon as I solve that these two and this becomes out of 12, and again this becomes like this, moving all of them with 12 ohms, and this is 6. Now as you can see, 6 and 12 are again in parallel combination, which will again give me 4 ohms. Again I'll solve this, again I'll get a resistance like this, and again I'll find that in this situation these three will be in series combination. Right? Are you getting this? So you have to solve it patch by patch, patch by patch, right? And then you will get the equivalent resistance for this whole circuit. Try doing this by your own. In this situation, find the current across each of the resistors. Across each of the resistors. See, point is that for finding the current in this whole circuit, I have the formula that is V is equal to IR. But that R should be R equivalent. Na? And these are three resistors. And three resistors means these two will combine to form one resistor like this, which will give me 8 ohms, and 5 plus 3 series combination 8 ohms. Then 8 ohms and 8 ohms are in parallel combination. So it's like 1 by 8 plus 1 by 8, which will give me 1 by 8 plus 1 by 8 will give me what? 2 by 8, that is 4. So ultimately for this whole circuit, the R value equivalent will be equal to 4 ohms, correct? Potential is 24. Current I need to find. R is 4. So the current becomes 6 ampere. Right? Now try to think about 6 ampere is the overall current, and that 6 ampere needs to be divided in this whole circuit. I hope you are getting this. This 6 amperes needs to be divided into this whole circuit. That means 6 ampere will start from here. 6 ampere will go here, and then 6 ampere will go here. I mean, obviously not exactly 6 ampere because 6 ampere needs to be divided in these two cases. The best way to find this is, I'll tell you a trick for doing that. I1 is to I2 is equal to 1 by R1 is to 1 by R2. Say this here I1 current is going and say I2 current is going over here. This combines to form 8 and this also combines to form 8, right? Although we'll use other methods as well, but this is one of the methods which can be used. And since here I1 1 by r is 1 by 8 is to 1 by 8, and if I solve this, this becomes 1 is to 1, right? 8 is to 8 will get cancelled out, and this will become like 1 is to 1. That means equal amount of current will flow in both the circuits. That means this 6 ampere will be distributed equally in both the situation. That means I1 value will be 3 ampere and I2 value will also be 3 ampere. That is, I can say that I1 is equal to I2. And this is a kind of common notion, isn't it? You are going from one position to another position, and there are two ways to reach your final destination. If you follow one of the method, and if you follow the first way to reach to your path, in this path you have resistance and you have traffic jams. In the other path also you have equal number of traffic jams. So the probability in that case of choosing the path becomes 50-50, right? You can choose any of these two paths, right? So in this situation, equal number of probability will be there. That means similarly, for dividing 6 ampere, equal number of probability will be there. That means 3 ampere over here and 3 ampere over here, correct? Now, this 3 ampere will go in 8 ohms resistance, and this 3 ampere will go for 5 ohms and 3 ohms both. So now I can say that if I write this value for 8 ohms, the value of current will be 3 ampere. For 5 ohms, the value of current will be 3 ampere. And for 3 ohms, also the value of current will be 3 ampere. Because this 3 ampere, which is going in this direction, 3 ampere, it is not getting divided now. So it will flow directly, and thus 3 ampere from here and 3 ampere from here will come and form 6 ampere here, 6 ampere here. That will be the end. Are you getting this? Right? Find the equivalent resistance A and B in each of these cases. See, all of these three are in series combination. So here it will be R1 plus R2 plus R3. Correct? That's quite easy, isn't it? Now, if I talk about here, see, R1. In this situation, you will find that from going from R1, as you proceed from R1, there are two ways of going this. That means R1 is in parallel combination with these two. But from R3 to R4, there is just one single way, right? That means R3 and R4 are in series combination. So if I redraw this, making this as 1, then R1, R2, followed by this, like this, and current reaches over. This becomes R1, this becomes R2, and this becomes a combination of R3 plus R4. Now R2 and R3, R4 are in parallel combination, right? As you can see over here. So I have to solve these two, which becomes 1 by R equivalent is equal to 1 by R2 plus 1 by R3 plus R4. Correct? R3 plus R4 and R2, which will give me the LCM as R2 into R3 plus R4. With the numerator, we'll have R3 plus R4 plus R2. So the R equivalent will be R2, R3 plus R4 divided by R2 plus R3 plus R4. This will be the value of R equivalent for the second question, right? Similarly, if you go for the third one, see, these two are in series combination, these two are in series combination, and both of them will ultimately give you the parallel combination. I hope you understand this. So this is quite easy. And similarly, if you go over here, see, these two are in series combination with a parallel combination in this, because there are two ways of reaching R1, right? As you move from here, there are two ways of reaching to R1, which means this is in parallel combination. So R2 plus R3 in parallel combination with R1. So then you will get the equivalent resistance R equivalent in this case. Are you getting this? Right? So this was regarding the types of the combinations of the resistance that we have. Please make sure that you are solving this, right? Bye bye.